Hi everyone, welcome back to the workshop, and it's repair time again. Yep, you know how much I like repairing. And it's a test instrument. It's a WaveSurfer 422 oscilloscope by LeCroy. I'll just take the cover off. It's in immaculate condition. One of my viewers, Gary, contacted me after my last video and offered me this unit here. Not for free, had to buy it of course, but I got it for a good price. It does work. It has power supply problems. It is only able to run off the DC input option on the back. Run it off the mains and it blows fuses. I think Gary or somebody has had a go at repairing it. There was multiple faults with it, and it's partly been fixed, but there's still outstanding problems with the power supply, so you can't use mains input, just blows fuses. So let's get you a bit closer in and let's take a look at it. So here it is, and as I said, it's a LeCroy WaveSurfer 422. It's a 200 megahertz, 2 gigasamples per second oscilloscope. I think it's about 2004 vintage, or at least that's when the manual seems to be printed for it. So I'm assuming it's from around that date. Of course, it is quite a large unit here. It's in immaculate condition, as I said. There's not a ding, not a scratch on it. These units here run Windows. I think it runs XP embedded or something like that, as far as I'm aware. You can tell it's a PC. It's got the PC interfaces on the side, Ethernet, USB, keyboard, parallel port, VGA port, sound, mic, and a serial port as well there. And on the back you've got the AC input here, and you've also got options for a DC input and also a battery option. You can get a battery module that goes on the back here, and obviously it connects in there for running off of batteries there. You've got an auxiliary output in the back, an earth, and that's about it. But like I said, it's a touchscreen unit, hence the fact it's quite sparse with controls, because obviously you're going to do you know, a lot of your selections on the actual LCD itself. It's a 2-channel scope, and it looks like you know, I know nothing about these scopes, but it looks like it's got active probes, because it's got the extra 6-pin terminal off to the side there. I don't have any of the LeCroy active probe scope leads, so obviously I'll just be testing it if I get it up and running with a normal scope lead. And you got it, looks like you got a USB socket on the front there as well. And over at the far left hand side you've got the power on off control. So I did talk to Gary, and the DC input on the back doesn't work either. He says you can hear a relay clicking inside when you input 24 volts at the back there, and he has had it running, but the way he got it running is he dismantled the whole thing, and because it's a PC based, he basically just got an ATX power supply and plugged it direct onto the motherboard inside, the PC motherboard inside, and got it working that way. And from there was able to verify that the screen and everything else was working. So there's obviously issues on the power side, not just the DC input, but the AC, the power supply as well. So I think what we'll do is, the first thing is, let's get it apart and let's take a look inside. Okay, we're inside at least the back end of it anyway. Now what we have got here, this is not the main power supply. This is the power factor control board here. You've got the AC input coming in the back here, directly into the power factor control board. And what this basically does is raise the power factor of the whole device, probably up near 1, something like that. I presume without it, it would have been actually quite low. But what this also does is acts as a bridge rectifier as well. You've got 240 volts in my case coming in here, and I think you've got about 380 volts DC coming out of here, which then goes down into the main unit there. There's a main board, I believe, down in the unit here, which generates all the split supply rails, etc. But basically this here just does the AC to DC. And you've got another couple of boards over at the side here. That's the battery interface boards, and there's a couple of cables here that connect direct there and wind their way down inside there. Exactly what they are doing, maybe for monitoring the battery cell levels, etc., that sort of thing. Now Gary did tell me that this power factor control board was in a bit of a state. I'll put a photograph up here of the power factor control board when he got it, and you can see it's pretty well burnt up there. Now he has repaired this as best as he can. It's a pretty easy test, a basic test anyway. It's to stick mains in and see if we're getting the 380 volts. A little bit harder to actually detect whether the actual power factor control's working. I'll need to bring in my power analyzer for that, and hopefully we should see something approaching a power factor of 1. And without delving too deeply into the power factor control IC itself, hopefully we should be able to sort of verify based on the power factor of this board as seen at the AC input here that it's working. And from there, the 380 volts, like I said, goes down into the unit, and it's all the supply rails are generated from there. Yeah, well, I would say that was a lot cleaner than the photographs anyway. Let's take a closer look. But wait a minute before we start here. I've just noticed something on the board here. There's a MOSFET down inside on this heatsink here. You can just about see it there. Now Gary did say that he did replace 2Q1, which is that MOSFET there, as part of the repair that he did to this board. It's a TO220 package. The middle pin is obviously on the TO220s is normally connected to the tab. Now there's no insulating kit on that tab onto the heatsink there. Now when I turn the board over here, those 3 pads there are the MOSFET. This top one here is the center pin, and then you've got the heatsink there on that 2 screws there. Now on the top side, that screw goes away off. There is actually a track underneath it, a pad underneath that screw that goes away off to some other devices. Now there's actually a direct connection or a free path from that pad to the center pin, and why that's not joined up, I don't know, because otherwise you're relying, if a heatsink, an insulating kit is not required, then basically that middle pin is going to be connected off to this track there and these other devices via the tab, down the heatsink, down onto the screw, and away off to this track here. I hope you can understand what I'm trying to get at there. It's almost like there's meant to be an insulating kit there, and that's why there's no direct connection on the PCB. So you can see where Gary's done a little bit of repair here. I think there's a diode across there. I'm not sure if that's factory or not, because I don't see a reason why it would be put in the back if obviously it was on the front. But we'll assume that's a factory mod. But you can see that some of the tracks look like they'd been vaporized by the original fault. And there's a bit of repair here. You can see that there's a little a wire going between that resistor and that diode there. Obviously I think that track must have vaporized, and similarly across here. The same sort of thing there. I do have the service manual, and I do have a full set of schematics for the entire unit, so we're off to a flying start anyway. So I think the first thing I'll do, I'm not going to touch this, I'm not going to attempt any further cleanup. I'm just going to put power into this power factor board and see if we're getting the DC output, and also let's see what the power factor is. Okay, I just hooked up the board to my power analyzer, and it promptly blew both the fuses on the AC input here. A couple of 4 amp fuses there. No drama, no big flashes or anything like that. It just blew the fuses. Now, so there's obviously still a fault with this board here. Niggling in my mind, of course, is that insulating kit for the MOSFET, but we'll ignore that for the time being, and let's just go over this circuit here and see if we can't find anything obvious offline. So over on the left hand side here, that's the AC input. You got a couple of common mode chokes, and it's a big filter arrangement here. You've got a couple of them, and some capacitors between them, and after the second one, just a nice little filter there, and then it comes on to the bridge rectifier itself, which creates basically the 385 volts there. There's also an opto-isolator here. There's the input there, the diode side, and there's a transistor on the output there, and I think that goes straight to a connector, and I think it's just feeding back into the PC, obviously, so it can probably switch some internal relays or whatever within the actual unit itself. So I'm just going to probe around in this part here on the AC side of the bridge rectifier and make sure everything's intact there. It certainly is at the input. I did that before I even put power into it. There was no dead short across the mains input there, but I just want to probe around and see what we've got, especially around about the bridge rectifier. So I'll just get my meter, there we go, and I'll zero off the meter. There we go. And the AC input is there. You can see the first capacitor directly across the supply input, and the 2 chokes, and then the capacitors between them there. You've got some surface mount one there and there, and then you've obviously got the through hole ones as well. So we'll just go direct across the mains input first of all, and that's no problem. And then of course your first capacitor there, that's no problem either. There is it should be a direct connection there, yeah, and there. And then this 4 here, that's your first choke, that's across the choke, and that's on one side. You're getting about 0.15 of an ohm, that should be okay. Should be similar on that side there, yep. On the output side of that one there, that's no problem. And then there should be a direct connection to there, the second capacitor, yep. And the other side, obviously across it, getting nothing, and then direct connection to the second choke, yeah, yeah, and through the choke itself, again about 130.13 of an ohm, and the same on the other side, roughly, yeah. And then on to, I think that's the last, yeah, it's a final capacitor here, so we've got a direct connection there, and then across it there. Nothing. So on the top side we've also got these surface mount capacitors. They're down to earth, so I just want to make sure that we're not getting a short across them there, not that side there, because it's open circuit there, it's probably, this should be shorted I think. No, the other side. That one's not earthed, this one's earthed. Oh, wait a minute, not got a good connection there, there we go. And should be no connection there, and this should be shorted I think, yes, and this should not be. So we've not got any leakage down to earth, and that's the top side one. So I think we're okay on the chokes and the filter arrangement there. And then you've got two tracks, this one here that snakes down to the bridge rectifier there, which is heatsink mounted, and on the other side of the board you've got the other one there. So the two centre pins should be the AC input onto the bridge rectifier. Yep. And we've got the DC output, the positive is nearest me, and the negative of that side there. So there's no short across the outside pins on the bridge rectifier, so that's fine. And then we've got that opto isolator here. That should be okay as well. Just double check that. There's the two. This is the diode side here. Well, at least there's no short. I'll just go into diode mode just to double check it. 1 volt, and the other way around 0.4. Of course we've got a back EMF diode as well across it as well. So one of them will be the 0.4, the other one will be the 1, so probably okay there as well. Right, just did a little bit of testing offline there. I hooked up AC input to my Ravistats, my variable transformer, and I didn't really want to throw 240 volts into this given the mess of the board that it was before. So I hooked up the Ravistat there and started off and fed it to, like 10 volts AC, and then not far above that it blew a 500 milliamp fuse that I'd put in here. There's supposed to be 2 4-amp fuses, but I stuck in 2 500 milliamp fuses just to a little bit of added protection there, just to see what would happen, and it blew a fuse. So what I did then was I thought, okay, I need to find out where about the problem is on the board. So what I did then was I removed this triac here and the resistor here. Let me just zoom in so you can have a look at that. So what I did was I removed this triac and the resistor here, effectively isolating the PFC chip, etc. And I was able then just to give it an AC input, and I was hoping to see a DC output at the bridge rectifier, and it was blowing fuses again. So I thought, oh, whoa, something's not right here. So I probed around on the board, and actually the bridge rectifier's knackered. Let's take a look. So I've got the old one here. I've actually put in another one that I had lying around. So if they've got the 2 AC inputs in the middle, positive to the left, negative to the right. I'll go across with my ohmmeter between the positive and one of the AC inputs. Dead short. Wow, no wonder it was blowing fuses. And obviously if I'd left the 4-amp fuses in there and whacked in 240 volts, this would have been pretty spectacular. But luckily I took a little bit of a precaution there, and you know, started off at basically 10 volts AC. So I then replaced the bridge rectifier, put the triac back in, put the 15k resistor across it back in, and hooked in an AC input, and it seems to be okay now. It's certainly not blowing fuses, and I am getting a DC output at the PFC output, which is the final output on the board there, the DC output. So there it is. I've got it running now, 238 volts input. I'm getting about 330 volts DC at the PFC output there. So it seems to be running. Right, I've now got it hooked up to the power analyzer here. So I'll just put power on there. It is just 244 volts is just the incoming AC, and the power factor 1 is because it's switched off. So I'll just switch it on now. And I'm getting 336 volts DC output, and you can see that I'm drawing about just over 20 milliamps, but the power factor 0.287, that's horrendously low. I need to do a little bit more investigation here. Not exactly sure how the power factor board kicks in and kicks out in terms of functionality, so I'll need to have a look at the schematic for that and see what's going on. But certainly 0.2 is not very good. I would expect it to be a lot closer to 1 since it's making use of a PFC chip. Okay, the next thing I'm going to do next is I'm actually going to put the power supply back in and connect it up to all these cables which arrived to me disconnected. And then I'm not going to put AC input, I'm going to put the DC input into the scope. It's, you know, it can run off of 24 volts, so I'm avoiding putting mains AC into it at the moment until I can establish what the status is with the main board power supply further into the scope. So I don't think there's any harm in connecting this back up and then running the scope off the DC. When I first got it, I did put DC into it. I didn't put AC into it. I put DC into it, 24 volts DC, and all you hear is it clicking. There's a relay obviously somewhere that's clicking when you apply power, but the scope never turns on. So I want to see if that scenario still happens now that I've got this board at least powering up. So let's connect it up and see what happens. Okay, I've had to take the side covers off of the scope, as you'll see, just to get access. The cables in the back here weren't quite long enough to plug into the power supply, the PFC board here. It's just awkward, and as you can see here, it's because a lot of them are down through these guides here, so I'm not really sure what's going on, but I'm going to pull some of these out of the guides so that I can get the power supply, the PFC board plugged in easily. Okay, got a 24 volt connection in the back, not powered on yet. Let me just turn it around. Right, so as I said, initially when I did this, all I was getting was a clicking. You could hear a relay clicking, but there was no life whatsoever and virtually no power draw. So I'll just put on the power supply, and we're drawing 50 milliamps. Let me push the power button. Wow, we've got power. It's drawing about 3.8 amps. Still drawing 3.8 amps, booting up. That looks like Windows XP to me. So obviously the PFC board is required, it's obviously got some logic connection somewhere to allow it to power up in its DC mode. But whether that means the AC input's going to be working, and importantly whether the PFC chip itself, the PFC circuit, is working, is yet to be seen. But this is a step forward. This is encouraging. No errors. It's drawing about 4 amps now at 24 volts. A big power supply, so there's no problem there. I'm good to about 10 amps. But we'll just let it boot. The touchscreen appears to be working. It's moving the pointer around anyway. More relays clicking. And scope software is running. Okay, I think the next test is to bite the bullet and put 240 volts into it and see what happens. So let me work out how to shut this down and reconfigure for mains. Okay, that's the power supply. Put back in. A couple of fuses. I don't quite have the right size. It should be 4 amp. I've got one 3.15 amp and one 2 amp, but they're HRC fuses just for that extra protection there. Stop it blasting everywhere if there's a serious problem. So hopefully that'll boot up. I've got it plugged into my power analyzer because I'm quite interested to know what the power factor is. So that's it plugged in. So just off camera I'll just go and turn on the AC. That's AC on, and I'll hit the button. Aha! We've got life. Excellent. So I'll let it boot right up. It's drawing about just over 100 watts. Luckily I can put the case back together because I can get access to the power supply to change out the fuses quite easily. I've had to order a couple of 4 amp ones. Now that's booting okay, so I'm going to check the power factor now. Here we go, so I'll just test that. 0.9, that's looking good. So obviously the power factor board needed to interact with the main board in order to enable it or whatever, so that's looking good. I'm quite happy with 0.9. Certainly a lot better than 0.3 or whatever it was. And that's it booted back up fully and looks to be operational. Obviously I'll have to get a scope probe and test it out, but looks like we've got another test instrument for the workshop. So I'll put the case back on, box it up. Thanks for watching.